Okay, today we're going to be thinking about our multiples. So we've got 10 cards, 0 to 9, and we've got to use all 10 cards. So I'm going to use each digit once. And I've got to make, first of all, 5 numbers that are multiples of 3. Now, well, there are 5 numbers, so I might think to myself, okay, I've got 2-digit numbers. Not necessarily the case, because I could have some 1-digit numbers and 3-digit numbers, for instance. But if I try to say, well, let's see what happens if I try to use numbers that are 10 or bigger and smaller than 99. Sorry, there's some lockdown here. That might just help give me a little bit more focus. So let's see what happens. Well, first of all, to use this 0, I think I'm going to start with 30. Multiples of 3, remember, the digits add up. If I add up all the digits in the number, it'll make a multiple of 3. So that can sometimes help as well. Well, I know, okay, 12 is a multiple of 3, so let's try that. 45 is a multiple of 3. 4 add 5 is 9, which is a multiple of 3. I know then, looking at these, well, 96 or 69, those are both multiples of 3. 6 is a multiple of 3, 9 is a multiple of 3. And 78, well, 7 add 8 is 15. So yes, 78 or 87 are also both multiples of 3. Now, that's not the only way I could have done that. There are lots of other ways I could have solved that problem, but this is just one example. 5 numbers that are multiples of 7. Now, this one is definitely a little bit trickier. And I think one of the things I'm going to do is I'm just going to write out some of my 7 times tables, first of all. So I'm going to do 7, 14, 21, 28. Again, just writing things down with maths problems can really help sometimes to help see patterns, solve problems. If I'm stuck, it gives me something to go back to. So I've got 91, 98, and then I've got 105 and 112, and I'll stop there for the moment. Now, say I started with, let's just get rid of these. Say I wanted to start with the number 7. So that's obviously a multiple of 7. 7 times 1 is 7. The next thing I'm going to do is I'm going to think about those digits where there are fewer options. So there are lots of numbers with 1 in, for instance, and with 4 in. So lots of options for that. There are not all that many with 2 in. So that's going to be a bit of an issue. But I've got 21, 28 that I could use. 42 as well. Not that many with 3 in. I've only got 2 3s here. So in fact, I'm going to start with the 3s. So my options here for the number 3 are 35 or 63. Now, the problem I then have is, well, look, if it's 35, I've used that 5, and 6 only goes with 5 here before 100. So that's not going to work. So that must mean, and similarly, if I do 63, well, I've used the 3, and the 5 can only go with 35. I've already used the 3. So that's telling me that I must have to go above this range. I must have to go into 3-digit numbers. So I can see that, for instance, I've got that 105. So if I cross out 63 and instead replace it with 105, which has also told me that I need that digit 7 just to be by itself, because I've used the 0 now, so it can't be 70, can't be 77. So there aren't 2 7s. So what have I used now? I've used 105, I've used 6 and 3, I've used the 7. So I'm now left with 4, 2, 8, and 9. And well, I can see I've got 42 is a multiple of 7, and 98 is also a multiple of 7. So that's 5 multiples of 7 that I've made using the digits 0 to 9. Quite a tricky one, that. And again, lots of sort of playing around with numbers. This doesn't work, that doesn't work. So that means I must have to change my assumption at the beginning. I thought I was between just using 2-digit numbers. That doesn't work. So I've had to use a 1-digit number and a 3-digit number as well. It's just playing around, experimenting, seeing what happens, but looking for those patterns all of the time.